Hello again. This is Edward, and this is a continuation of the Gamemaker tutorial. In this one, we're going to very quickly look at two brief things. They're going to help improve the simulations and give you good ideas on how to take it further. Again, we're going to put this magnification box in the right-hand corner so you can see some of the more complicated stuff we're going to be doing. Okay, now, the first thing we're going to look at is reducing this collision size for our pedestrian. As you can see, we currently have precise collision mask detection selected. But now what we want to do is we want to say, well, I want a big image for our pedestrian, but we want it to be able to go through very small spots. So we can do this by going into our modify mask option. And underneath this, what it will do is we can go to zoom in, where we can zoom in by several levels. And instead of setting it to automatic, where it will do it to the boundary of, you can see that, oh wait just a second, I'll clear it, we'll go manual. So you can see I'm drawing out a collision box now. Now what this is this will decide where our particle is, in the sense that it will only consider it to exist at these areas, but the image will just continue. So what we're going to do is we're going to make a smaller collision area for our pedestrian. This will allow it to move through smaller locations. So we can just test this right now. You're not going to see an enormous amount of difference, but it does improve its pathfinding slightly. And when you're doing something kind of in an 800 by 800 area, you want it to be able to move through smaller gaps. But the simulation will still show them as being quite large and show them moving through that kind of space. The next component that we want to do is we want to say, well, you know, we want to do something a little bit more interesting than just showing the outlines. So let's say that we had our setup here. So let's create a new layer in our Photoshop document. So these are our streets, and we want to say, well, there is a reason why people move faster. Let's say our theory is people move faster or slower based on where they are within the area. So let's do that. So we'll drag it under here and we'll say, well, people move much faster when they're on hard surfaces. So we're going to say anywhere that's green is a soft surface. So we're showing some soft surfaces that are apparently in this area. And we're going to, I'm just throwing in some random green. Alright, so let's save this out like we did with our street structure, but this time we're going to save it out with just our, call it a grass pattern. Now we're going to load it up in exactly the same way as we loaded up our streets. So what we want to do is we want to go sprite, load sprite, grass pattern, just like we did with the streets. You can see there's a clear portion and a solid portion, and we want precise collision detection for it. And we're going to call this one grass. Let's create a new object called grass. We don't want it to be solid because we don't want our pedestrians to be colliding with it. And we're going to press OK. Something has just occurred to me. We're going to save this as pedestrian 4 so that we have 2 copies of this file. Okay. So, and now I'll save it as pedestrian 3 as well, and we'll delete that component. Okay. So now we've got this other object, and we're going to call this grass as well. Usually it's best to try and name your images and your objects differently. Otherwise it can be a little bit confusing. Alright, so we've got our grass image, and now we have a grass object. Now we want the grass to be drawn at the very bottom, so let's just set it to 20, so it's the deepest object drawn, and we don't want it to be solid, otherwise our pedestrians will collide with it and not be able to get around it. So let's just throw it in the room, so now it's looking somewhat more like our Photoshop document. And we'll close the form and save the changes. Save that out. And now we're going to go to urban, and we're going to say, our pedestrian. And we're going to create a little bit more complicated movement code. So now when you go into here, we can separate different components of our code under control using these little arrows. So it means whatever happens in these arrows will happen separately and at the same time as whatever happens outside of those arrows. And the reason why we're going to do that is we're going to set 2 movement speeds. So let's copy and paste our step towards command. So let's make it step towards at speed 0.5. This means they're going to move very slowly. They're going to be moving at 1/4 the speed on that. So we have one that's at 0.5, and we have one that's only that's at a normal speed. So how are we going to set it up so that it will move at one speed if there's on top of the grass, and move at another speed if it's not. We can do that using a very simple command under control, which is called else. If we drop else command, it means that if a condition isn't met, and we're going to put the condition in front of this, it will move towards there. So now we need to set a condition in front of the step towards. So we need to say, like we did with the pathway, we need to say check for grass relative to yourself. So check to see if there's grass there. If there is grass there, it's going to move at 0.5. If there isn't grass there, else is what that command is. If this condition isn't met, it will step towards it at a speed of 2. So now when we run that, you can see them moving very slowly across the grass. And in fact, in this case, they're not even making it out of the grass. So what we're going to do is we're going to say, well, let's just move our stations, because our stations are in the middle of grassland. Now you see, what I've just done is I have deleted the street pattern, because the order in which you lay them down in your editor is going to decide the order in which you play around with them. Usually I try to make it simple enough that it's pretty easy for me to readapt it in the order that I want. So let's throw down the grass, throw down our urban fabric again, and you can see that it's put that on top of the other because of the depth settings. And now we're going to put our stations outside of the grass areas. Now remembering that they're going to appear at the center of the station, so it doesn't matter if it overlaps just a little bit with our urban fabric. There we go. So let's run this and see whether or not we can see a clearer image of them. Yes, now. We can see them moving out, and now we can see them slowing down when they hit the grass areas, because now the grass areas are in the way. So this is a way that you can begin to allow for a little bit more interesting functionality. There are other interesting elements we can do, in which we can play around with things such as animations on the pedestrian. This is pretty easy to do. You just go edit sprite and say copy and paste. We'll create another one. If we make the second one different, let's say red, it's going to flicker between red and green. We can go to animation tools. It's really very easy to use. You can stretch the length of it to be, let's say, 30 frames, so it'll only flash once per second. Now when we run it, our little pedestrians are going to flash red and blue, red and blue. That's not enormously useful, but you know, it can be interesting if you want to add some animations to your pedestrians. You can also, I think, if you want to experiment with what your pedestrians look like, there's this little function under main 1, and you can set the image of your sprite. So when we put in or change the speed of your sprite, when we put in our animation, you can see that there are 30 sub-images. This means there are 30 frames to the animation. So when we click through them, it will display which of our sub-images we have. And so what happens is when we drop this into here, we can choose the sprites. We want it to be, say, the 9x9 circle, and we can tell it what sub-image do we want to choose, what speed do we want it to choose. So in this one, what we could do is we could theoretically go, well, let's stretch this back to 2 frames. So we've only got 2 frames. But what we want it to do is we want it to show a different color depending on where it is. So let's say we want it to have a speed of 0. This means it won't animate, but we can ask for a sub-image. So let's say we want it to be sub-image 0 when it's on the grass, and when it's not on the grass, we want it to be sub-image 1. And now let's see what happens. See how they're all red? Oops. Okay, now. This is because I haven't bracketed our operations properly. In many ways, this occurs... the way to look at the way in which these animations work, these commands work, is they work like maths. What you want to do is, if you want them to do both of these things, or both of these other things, we're going to put brackets around them like we're putting brackets around it in math. So it'll do this entire column separately, and then else, and then the other. So if you look at the structure of this, we have, if there's an object at position, do everything within these brackets, otherwise do everything within these brackets, and then we end the bracket, and then we add another one to the end there. And now we should be able to get a different sub-image. Yes, now you can see them turning blue when they hit the grass. I've put those stations in terrible places, so it's very hard to see. But what you can really do is you can begin to experiment with exactly what they're going to look like as they move over objects and obstacles, and you can change what kind of effect these things have to them. Does it make it slower? Does it make it faster? Does it change their color? And you can even set it up such as that it will change what kind of object it drops. So let's do that. So we're going to stick down, let's just make a station so we can see a little bit more clearly. Oops, see daisies. Put one there. We'll put one right there and put one here. Alright, so now we're going to create something a little bit more interesting. So in this one, we're going to set up a different looking circle. So we've got our 5x5 blue circle. So let's edit this sprite and make this one yellow. And we're going to split our distances into two values. So we're going to call this 5x5 underscore yellow. So now what we're going to do is we're going to duplicate our path object. And now we're going to show you a really interesting little trick. We're going to say parent. You see this little value here, parent? And we're going to select path. And we're going to call this yellow path. Now, parenting is an interesting component. The only reason why I'm showing it this way is because now we have two objects, but when it does the check action, it will act as if it was its parent object. So it will say, is there already an object there? It will consider both the yellow path and the path to be that object that it's going to avoid. So now we're going to go to our pedestrian 1, and we're going to say, well, every step we want you to also, and in fact, here can be a really good use of the copy and paste. Let's just copy this whole block of programming that we did for what kind of path. And now we're going to throw down a whole new set of commands. So we're going to say, well, is there, let's create two different kinds of path. We've got a yellow path and we have another path. Now, part of the problem with this particular type of equation is we're like, well, how are we going to... Oh, I've just managed to accidentally break that code because I copied and pasted improperly. Alright, so what we're going to do here is we're going to copy this entire block of code and paste it down here. This just makes it easier to delete out the old bits that we don't need anymore. So now we don't want it to... And we'll go yellow path, so that way it's going to create a yellow path or it's going to create a path. And it's going to create that relative. But instead of doing it just where there is grass and where there isn't grass, we want it to do something a little bit different. And this time we want it to create depending on how old our particle is. So we can do this by setting up what we're going to call a relative variable. So like we did before, instead of putting it into our create command, we're going to stick a new variable into our step command. And this variable is going to be called lifespan. And this is a number that's going to increase by 1 every step. So 30 steps a second, it's going to increase by a step. So we've got here a value associated with it, which is 1. And because we've set it to relative, it means it's going to set it to an extra 1 on top of whatever the current value is. So this value is going to continue to climb until it gets to the end of its lifespan. And we know because when we created it that its lifespan is going to be 120 steps. So we can add a new check in. So instead of checking to see if there's an object available, we can check the value of our increasing variable. So if we stick it in front of this here, we can say, is lifespan greater or larger than 60? If the lifespan is greater than 60, it's going to create a yellow path. Otherwise, it's just going to create a normal colored path. And then every step is going to increase that lifespan until it's destroyed. So let's see whether or not that had the desired effect. No. what we've done here is we have set a... It's useful to make these mistakes because I can show you how to solve them. In the Pedestrian, we cannot increase the lifespan by 1 unless it's already got lifespan as a value. So let's go into Create, under the Create command, and add lifespan. And this time we're just going to set it to 1. What you need to do is it will say take lifespan and add 1. If you haven't already said what is lifespan, it's going to get confused. So in the Create command, we're going to create set variable lifespan, and underneath this, we've got lifespan relative to 1. That means it will constantly be adding a lifespan. So now you can see how instead of simply just getting a blue area, it starts off blue and it becomes yellow when they've become a certain age old. Now remember that as the particle moves, you can have it detecting different components, you can have it taking a different information about the urban fabric that you want it to, and then what you can do is you can relay that into some sort of information that you want to be able to print out on this. So hopefully you were able to follow that, and that should give you some interesting ideas of things that you can potentially do when you create your simulations in the future. Thanks very much.